yesterday we talked about the rectangles where the diagonals are congruent, right? Okay, so right here when it says it's a rectangle, from now on, I don't have to put marks on the shapes like I've been doing. Now when I say a rectangle, I want you to automatically start assuming some things. So the two things we learned yesterday about a rectangle, we just said diagonals are congruent. What was the other thing? Opposite reciprocals, the sides have to be perpendicular, absolutely. One more thing. What happened on the inside? There are two pairs of parallel sides. What happens on the insides of a rectangle? There are alternate interior. What else? What shapes are on the inside?
Triangle.
What kind of triangles?
Isosceles.
Isosceles triangles. So remember, all of these are now going to be congruent, right? So on this warm-up, when they said ZX is what? A diagonal. And then they talk about WY. What do we know about those two diagonals? They're equal, just like a dollar bill and 4 quarters. Do they look the same? No, they don't have to. So 6x minus 4 is going to be equal to 4x plus 14. 6x minus 4 is equal to 4x plus 14. Now what? Subtract what? Good. Minus 4x from both sides. Then I would add 4 to both sides, right? So 6x minus 4x is 2x. 14 plus 4 is 18. Now what? Divide by 2? Absolutely. So now I know that x is equal to 9. Did they ask me for x? No, they asked me for zx. So 6 times 9 is 54. Minus 4 is 50. And it's not 50 degrees. I've been writing that all day for some reason. It's just 50 because we're talking about the lengths of sides, right? Or the diagonal. Well, if this diagonal is 50, how big is this diagonal? 50. Other thing. Very good. Okay, next problem. Want that information clear? Now we're on to the next problem. It says if WY is 26, how big is this piece right here? 13, because we cut each other in half, right? So now I have a 13 and a 13. I know that automatically. Don't wait for me to tell you those things, right? And then they want to know, well, if WR is 3y plus 4, oh wait, isn't that the same thing as this? So now I know that 3y plus 4 is equal to 13. Now what? Okay. So 3y is equal to, what is that, 9? Divide by 3. So y equals 3, and that's what I was looking for. Okay. Next one. Says the measure of angle WXY. WXY. How big is that angle? 90 degrees. It's a rectangle, right? Okay. So now I know that 6a squared minus 6 has to be equal to 90. Now what? So now I have 6a squared is equal to 96. Now what? Divide by 6. Excellent. So now a squared is equal to, what is that, 16? And then I take the square root of both sides, so a is going to be equal to 4. And that's all they were asking for was a, right? Are we okay? Do you understand where this is going? All right, now we have another triangle, another rectangle. And they're asking for the measure of angle VRS. VRS. They're asking for this angle right here. What would I do? It's a rectangle. What do I know about this whole thing right here? It's 90. Do I already know a part of it?
Yep.
How big is a part of it? 38? That's okay. So 90 minus the 38 gives me what? 52? So this angle right here is 52. The next one says, well, what's the measure of angle RVU? RVU, this angle right here, how big is it? What would I do to find it?
Well, the two isosceles, you take the 38, 38.
Ah, so this is an isosceles triangle, so if this one is 38, this one is 38. Good, it's a triangle, so it has to equal 180. So 38 and 38, what is that? 76, so 180 minus the 76, 104. Are we okay? Questions? All right, so now we're going to take it to the next level and start going back to some of the graphing stuff that we talked about. We're still talking about shapes. A rhombus is a crooked square. Why? Because all the sides are the same, right? Okay? So that's really the new thing for the rhombus, except for one other thing that we're trying to discover. Okay? So we're going to graph the following rhombus. How in the world do I graph y equals 3? Is it horizontal or vertical?
It's horizontal.
Remember, hoy, lux, or if I want y to be 3, what do I want the x's to be? Does it matter? No. So we're going to do 1, 2, and 3, right? So I graph 1, 3, 2, 3, 4, 3. That means this line right here is y is where y will always be equal to 3, because right here, my y values are all 3. What does it tell me to do next?
Tells you to move it down 6.
Good. It tells me to translate or slide 6 units down. So 1, 2, 3, 4, 5, 6. We'll put it right about here, correct? And I'm translating the whole line. Question, what would that be equation be? Y equals what? Negative 3. Very good. Negative 3. Okay? And then they want me to graph this one. This one on my sheet for some reason is hard to read. It says y is equal to 4/3 x minus 5. Somebody help me out. Where would I start? At negative 5. That's my y-intercept. Let's put a point. And then what would I do? Good. Up 4 and over 3. I'm using that slope. 1, 2, 3, 4. 1, 2, 3. Here's my next point. 1, 2, 3, 4. 1, 2, 3. So that means that that line now looks like this right here. Are we good? Now what? Now what do they want us to do? Okay, it's saying translate equation 3, equation number 3, 10 units up. Okay, so just take one point and move it up 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is the slope of the line going to change? No, remember it looks exactly the same. So from that point, I can then go up 4 and over 3. Or remember I can go down 4 and to the left 3. So really what I have now is this line right here. Everybody okay with that? Do you see the shape that they're talking about, the rhombus? Where is it? Good, it's in the middle of all of these lines. This is my rhombus in here, correct? Everybody got that? Well, how do I know for sure that those lines or the sides are all congruent? Well, I can count them, but notice right here, these points don't land right on the middle, do they? So I'm going to check out this slope. It was up 4 and over 3, correct? Well, what's half of 4? 2, what's half of 3? What's half of $3? $1.5, $1.50, right? So if I go up 2 and over 1.5, that's where that point is. That point is right at a half. Everybody okay with that? So how long is this side right here? I can just count 1, 2, 3, 4, 5, 6, 7.5. What about the bottom? Well, same thing, down 1, 2, 3, 4, 1, 2, 3. This is right on that point. But right here, this one, I have to go down 2 and over 1.5. This is still in the middle. So I'm going to count it. 1, 2, 3, 4, 5, 6, 7.5. So wait a minute. How do I know about these other sides? Because I can't just count them. What would I use? The distance formula or Pythagorean theorem. Either way is fine. So from this point, I'd go down 1, 2, 3, 4, 5, 6 units down. Sorry, that was a little crooked. And then from here to get from here to here, isn't it halfway? So this would be 1, 2, 3, 4.5. So 6 squared plus 4.5 squared equals my c squared, and this is my c, right? What's 6 squared? 36. What's 4.5 squared? Well, 4 times 4 is 16, so it's got to be bigger than that, right? So somebody in their calculator, 4.5 squared, what do we get? 20.25. So 36 plus 20 would be 56.25. And then I have to take the square root of that, right? Well, 7 times 7 is 49. 8 times 8 is 64. Is that kind of in the middle? You think that's going to be about 7.5? So somebody, what's the square root of 56.25? Aha, it is 7.5. And I would do the same thing over here, wouldn't I? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4.5. Same numbers, same answer. This side is also 7.5. Are we okay? Shaded it in. Okay, now let's look at the diagonals. Are my diagonals going to be the same length or different lengths? On a parallelogram, are my diagonals the same or different? On a rectangle, are my angles the same or different?
It's the same.
Well, what if it was a square and I made it crooked? Wouldn't they be different? If it's slanted, those diagonals are going to be different. If they're 90 degrees, those angles will be the same. Okay? So let's take a look. What does it ask me to do? Let's draw the diagonals and write the equations of the lines. Well, what's the equation of this line right here? Is it a positive slope or a negative slope? This one right here. It's a positive slope. And I'd have to go up 6 and over how many? Well, that would be 7.5, 8, 9, 10, 11, 12. It would be up 6 and over 12, right? And you told me it was a positive slope, and what does it go through? It's hard to see on mine, but here my axis right here. What does it go through? 0, right? So my equation is going to be plus 0. What about the other diagonal? That's this one right here. Is it a positive slope or a negative slope? A negative slope. And it also goes through 0, 0. Would you agree? And then my slope is what? How many up and over? It's negative what, though? So I'd have to go down 6 and over 3. Down 6 over 3. Can you tell me anything about that? Perpendicular, those numbers aren't even the same. You have to simplify them. So this would be 1/2 x plus 0. And this would be negative 2x plus 0. What do you notice? They're perpendicular. Very good. So not only do we know that a rhombus has congruent sides, but now we know And watch how awesome this is. Watch. Are you ready?
Yes.
Not only